Most fluids can be classified between three different variations. For a normal Newtonian fluid, viscosity remains the same no matter how much shear stress is applied. A good example of this could be water. The way that it acts can be predicted in accordance with temperature and pressure. Non-Newtonian fluids do not behave the same way. There are two different variations that are shear thinning and shear thickening. The rate of shear and strain varies with the applied stress in these types of fluids. An interesting example of shear thickening in non-Newtonian fluid would be cornstarch and water. The solution looks like it would behave as water does, but is actually very different. This is going to be the fluid that we focus on today. It's much easier to create a non-Newtonian fluid than what most people think. Most people can do this with everyday fluids around the house. An easy example of a shear thickening non-Newtonian fluid will be a simple cornstarch solution that is composed of only water and cornstarch. To create it, you simply just mix the two thoroughly until the consistency is that of glue. When the force is applied, the fluid becomes very viscous and acts as a solid. The higher the force, the higher the resistance is to that of other objects, such as my hand. If the force applied to the surface is small, the fluid is more accepting to objects. As you can see, my fingers can enter the fluid much more easily whenever I barely touch the surface. This solution kind of acts like quicksand. If you were to stand on it, you would slowly begin to sink and fall into it. When you were trying to get out, the force of your body acting on the fluid surface would cause it to become very viscous and would make it nearly impossible to escape. Next, I'm going to show you how a golf ball reacts to the fluid. Whenever you set the golf ball slowly on top of the fluid surface, it will eventually sink to the bottom, but it'll do it very slowly. Using the same golf ball, I'm now going to drop it from about 4 feet above the fluid surface. Due to the high force, the ball does not immediately sink, but sits on top of the surface momentarily before it slowly makes its way down to the bottom. This concludes our experiment with shear stress and how a non-Newtonian fluid reacts to different forces applied to it. Thanks for listening, and hopefully you have a better understanding of shear stresses.